So now I guess you could see my screen, right? And the voice is also clear, right? Do I need to make any adjustments? No, I believe you can see my screen, right?
Yes.
Yeah. And firstly, thank you so much for joining this session on advanced generative AI. So so this program is specifically designed to be job oriented, giving you the practical skills to build a career in one of the uh, today's most revolutionary fields, which is generative AI. So firstly, let me introduce myself. This is Naveen, and I have close to overall 9 years of experience. So I have been graduated from NIT Trichy in 2016, and I have been working as a software engineer from then. So currently, I'm working as a AI specialist. So in one of the product-based companies, so banking domain, and I'm a part-time generative AI trainer, right? So this is all about myself, and uh, about this program, we'll look into that in the coming few minutes. Okay. So before that, let me take you.
Working on same technology or other, Naveen?
Same technology, it is same technology. So I was working as a AI specialist. So current earlier I was working on this machine learning algorithms from the starting. I mean, when I started my career, so I was working with the machine learning algorithms and models only. So after that, when generative AI has come up, so during this 2018 and all, right? So um 2018 it was started, but I have close to around 3 years of experience in this generative AI technologies. So because the generative AI has come up from, so it was booming from around 3 years. So I have been working in this particular technology in the same domain. I mean, okay. So from then, yeah. So yeah. So before we go any further, hope you can see my screen. And this is a basic question everybody gets, right. So let's ground ourselves in the foundational concept. What is this artificial intelligence? Okay. So at its core, AI is a broad field of computer science that we already know, dedicated to creating systems that can perform tasks that normally require human intelligence. Okay. So this might be confusing for you if you are not from any machine learning or AI domain, but it is nothing but whatever the human intelligence we have, and we are able to do some tasks, right? And if we could make any based systems to do that way, so that is nothing but your AI. Okay. So these are the key capabilities for even for us as well. See here, and if someone we if we want to have take any kind of decision in our life, so basically we'll going through some kind of logics, right? And we have been learning, and we have been making some decision making in our lives. So just like that, even artificial intelligence, a computer based system with this capability, is able to have these four key capabilities. So that we are seeing already by using chat gpt or any kind of llms, right? And we are very much surprised by their capabilities. Now if we can share our screen and show this is happening using this google ai studio. You can share your screen and say this is happening in my code, or this is what I'm doing right now. It is able to give you suggestions on whatever it sees. Okay. And if you send it some documents, it can read and it can answer to you, and it can talk to you. So all these capabilities whatever a human is having, artificially we have invented that, and it is nothing but your artificial intelligence. That particular technology is artificial intelligence. Okay. So I think there is a light gap, so I would like to keep things simple. So let us see artificial intelligence in simple terms. Okay. So AI is when machines think and act like humans. So this we already know, that we have seen, and it can learn, solve problems, and make decisions. Okay. So this also it is self-explanatory. I need not to give any uh, more explanation on it, because you already know a lot about it, right? It can learn, solve problems, and make decisions, right? And coming to So this is a broader spectrum of artificial intelligence. Okay, so artificial intelligence is a major field we have here, and you can see some kind of subfields like machine learning, deep learning, and generative AI. So these are all the subfields of artificial intelligence. So artificial intelligence is a broader field and these are subfields of it. Okay, and each of the field here, it has its own importance and it has its own applications, and it has its own significance on our life as well. Okay, that we will be seeing in the coming slides. All right, so yeah, so I kept a small video on this. So self-driving cars or simple robots or even some kind of simulations and analysis, right? So we have been using AI in many ways, and these are very few of them. You can see this autonomous vehicles, right? Self-driving cars and all. So that is the thing. Okay, now it is time for us to understand the AI ecosystem. So what is this and what is AI? We have just learned machine learning, deep learning, and generative AI. So as you are going to become a generative AI engineer, you are going to have a knowledge on generative AI. So it is required to have what are all these fields basically. Okay, and on the right side, let me tell about this person. He is Geoffrey Everest Hinton. He's godfather of artificial intelligence, we call him, right? And so godfather of artificial intelligence, if they have given that title, so he would have done lots of contributions, right? Yes, he has done a lot of contributions, particularly in the field of deep learning. Okay, even the LLMs that we are seeing right now, so which are part of your generative AI, chat GPT, open this Claude or Gemini, something like that, they are all kind of applications from deep learning itself. Deep learning is a head, like a backbone kind of for generative AI. You're going to see that. So that is the connection we have between these fields that we will see now. And this person, he has major contributions on deep learning, and most of his contributions will be on that. Okay, I mean the deep learning, so how to build up these neural networks and all. So he did lots of achievements on that. Okay, so now it is time for us to have a look at a few things. Okay, so yes, I was telling you, right? So what is artificial intelligence? Artificial intelligence is nothing but a field of computer science. So let me take my pen. So the field of computer science and focused on creating machines or software that can perform tasks with which normally require human intelligence. Okay, so basically whatever the technology we have right now, it is not at all matching human intelligence, but instead I could say it is surpassing the human intelligence. Okay, so AI is surpassing the human intelligence in many ways, that we will see up. Okay, and coming to this machine learning, what is this machine learning? You wouldn't heard about this machine learning at all, right? So let us see what is this machine learning is all about. As you can see over here, machine learning is a subfield of artificial intelligence. Okay, so a subset of AI where models learn models, or models can also be called as algorithms. Okay, in a shorter form you can call it as algorithms. So where algorithms learn to make predictions or decisions by finding patterns in data. Okay, rather than being explicitly programmed for every scenario. Okay, what does it mean actually? So what does it mean? So machine learning algorithms work in such a way that we will be sending a lot of data to it. Okay, so data to machine learning algorithm or model. So what it will do is that it learns patterns in that particular data. Okay, whatever the experience and salary if a person is having, so that pattern it will find up, and it can predict the new salary of a new hire. If a new person is coming into our a company, then this particular algorithm, if you build on this particular data set, it finds the pattern, and if it finds suitable relationship between employee salary and employee experience, and it can automatically decide the salary of that particular employee. So that is nothing but finding the patterns in data. Okay, so that's what we will see in the next slide. What is machine learning? So machine learning is the field of artificial intelligence that you already know. And in machine learning we will have a couple of algorithms. Okay, in sometimes we can call algorithms as models. Okay, so algorithms are nothing but the techniques that we use for building the models. Okay, so there is a slight difference, but people usually in a real time they usually interchange the words and use them. All right, and the applications of machine learning is what we are going to see now. And data importance, so it will, so the importance of data is something matters in machine learning. You'll have to send a lot of data to train your models. Okay, so train your models so that they capture the beautiful relationship between two things. One is being your I mean, just the example I'm telling, right, the salary and the experience that person might be having. So this relationship our machine learning model will be capturing inside, and do that task of predicting the salary of a new employee altogether. Okay, so that is machine learning. And now let us see what are all the applications of machine learning. So for example, if you are using Gmail, and if you get any kind of spam email, it will be automatically segregated and moved to this particular spam folder. And if it is a promotion ones, it will be going to promotions. And just like that, it will be moving automatically when you get an email, right? So this segregation of spam emails and ham emails, so we call the clean emails as a ham emails for now. Okay, so ham emails or non-spam emails, it will be able to segregate on its own. All right, so that is the algorithm behind this Gmail, which is nothing but your machine learning algorithm itself. Okay, so and there is one more, I mean, we have lots of applications of machine learning. So and you can take this particular website as well in Flipkart or Amazon or in Netflix or wherever it is. So once you purchase a product or you show interest on any product, automatically you will be getting some recommended items, right? So this is also an algorithm playing behind. Okay, so these are also maybe a part of machine learning itself. Okay, of course it is machine learning, but we have a technology again, right, the deep learning. So it has replaced many of the applications of machine learning. Okay, so that we will be looking it into. But even before some 2010s also we were having some applications. And we have some rule based systems, or we were having chatbots for IRCTC or something like that, right? So whatever the chatbots or systems we had, so those are all built on machine learning itself. Okay, and if of course in this Google Maps as well, Google Maps has come up long back, right? So it will be telling you the shortest distance, or how much time it might take. So these kind of applications also have a machine learning algorithm behind them. Okay, so these are few applications of machine learning. However, we will have a lot of it. Okay, and then so we have learned about what this machine learning is all about. So what it will do is it will capture the relationship between the data, or it will capture the patterns inside the data. And then so whatever it finds, once you train it on the data, that becomes your model. Okay, using that model we can create any kind of applications like this, or support to the applications. So that's what the machine learning is all about. Okay, now let us move to the other subfield we have, which is deep learning. Okay, so deep learning is also, I mean, it is very important even for a generative AI engineer, because whatever the LLMs or the things you see in generative AI, those are all some kind of applications of deep learning itself. Okay, so let us see what this deep learning and how important that deep learning. Okay, so deep learning, so as you can see here, it is a subset of ML. Okay, that is sure. So it is a subset of ML which uses artificial neural networks. Okay, so this time you might this term you may not have heard about this particular ANN before. However, let me show you what this ANN is all about. Okay, so this is a definition of deep learning. So don't get confused. One thing I would like to say, okay, so let me write over here itself. So beside this deep learning itself, so actually what happened was in 1943, two scientists were there, McCulloch and Pitts. Okay, so what they did was, so they thought like, can we create a machine? Can we create a machine or an algorithm which can think like human brain? Okay, human brain does. Okay, so however our human brain works, okay, so so for example, if I am delivering some speech to you in this particular class, many kind of processings would be happening inside my brain, especially. Okay, so some kind of calculations or word formations or connectivity with the mouth and all, I'm speaking out, right? So all these processings are happening inside my brain. Okay, so what they thought was, whatever the processing is happening inside the brain, so can we replace, I mean, not replace, can we make a machine which thinks or which works exactly like a human brain? So that was the question those people have got that time. Okay, and they proposed an algorithm, and we will see what it is actually. Okay, so on the left side you can see, right? So this is, so right, a brain is made up of billions of nerve cells. Brain is made up of bre- of nerve cells or neurons, you can call it as neurons. Okay, so these neurons actually look somewhat like this. Okay, in real time they might look somewhat like this. So we have input layers like dendrites. Okay, so for example, let's say at this point of time, somebody has pinched me. Okay, pinched me on the leg, and that signal, it passes to my brain, right? So this is how it passes to my brain. Okay, I mean, this is also inside brain, and inside brain, so we have a single unit called as nerve cell. Okay, we have billions of nerve cells, and I have taken only a single nerve cell. Okay, so dendrites are the part where it takes up the information, and cell body is something a part which process that information. Okay, somebody has pinched you at this place. Okay, so cell body is something it process, and it finds that that signals it is receiving is nothing but your pain signals, and at what part of the body. Okay, so the actual processing will be happening inside this particular part. Okay, and then we have on the right side synaptic terminals. Okay, so synaptic terminals, so this is how a nerve cell looks like. If you remember during your 10th standard and all, we had these diagrams in our biology. Okay, so I mean, I just kept that with some kind of animation, but however the principle being the same. So we have these synaptic terminals, and whatever the processing happens, it will be sending some output to this synaptic terminals. So synaptic terminals are nothing but your output layer kind of. So this particular output layer, it will be connected to some other nerve cell here, some other nerve cell, and so like this. So uh, information is passed from one nerve cell to other nerve cell, like a network. Like a network, information passes. Okay, so if you call that particular network as natural neural network, let's say these are all nerve cells, so we can call it as natural neural network. If you call it as natural neural network, okay, and those people, I mean, the researchers I was telling you, right? So they wanted the same working or functionality of this nerve cell artificially. Okay, so they made something like this, okay, algorithm, something like this. So what they did was, they created this input layer serves the same purpose as dendrites we have. It takes up the information. Okay, and then we have the hidden layer which process that information whatever you are getting. Okay, so this is the hidden layer where the processing will be happening just like your cell body. and we have the output layer which creates the output to the other neurons or other neurons. So if you call this as natural neural network, okay, what can you call the other one on the right side? It can be artificial neural network, right? Okay, artificial neural network, right? So deep learning is all about study of those artificial neural networks, is called as deep learning. Okay, so this is the point. And so this might look very simple to you because we just invented a network which is artificial, but you know how many wonders it has created in real time. You'll be surprised by that. So see, these are all the applications of deep learning. Of course, I can keep this as 20 point applications, but I wanted to keep this as short as possible. Image recognition, right? Image recognition, if you are using your mobile phones where your mobile detects your face and then only unlocks, okay? And of course, we have few other things like, you know, when you open Facebook and you might be having some photos with your friends, right? And automatically that particular Facebook algorithm will find who are all the friends in the next photos. Okay, so this person in the is in the first photo, and if you tag him, so it will remember that face is related to that particular person, and in the second image it automatically detects. Okay, so these kind of things are kind of image recognition. And of course we have been using this particular technology in even the medical studies as well. Medical studies in the sense x-rays. So people, if they have any kind of cancerous tumors or something, so we are able to find those uh, minute features as well from those particular graphs and all, using this particular technology, deep learning. Okay, so that is about your image recognition. And you know about this natural language processing and all the chatbots and all you are already using, right? So chat GPT, Claude, Gemini, or whatever maybe the chatbot or LLM you are using. One second, please. Yeah, thank you. So whatever maybe the LLM you are using, so all those LLMs are working on the principles or of deep learning itself. All right, so this is the other thing. And of course we can keep many things over here, but I'm just keeping, see here you can see, right? Chatbots, language translation, and sentiment analysis. You know, so what is sentiment analysis? So for example, if you go to a movie and you for example, let's say book my show or IMDb, you are giving a review of that particular movie. The movie is excellent, the movie is outstanding, or the movie is boring, the plot is very boring, and the actors did not perform well. So those kind of sentences will be giving as a feedbacks to the movie, right? So our model, it automatically finds what sentiment it is. So if we say that a movie is excellent, our model is able to say that, so it is a positive feedback given by our customer, okay, or audience kind of. So even a model or a machine is able to know what is the sentiment of a human, right? That is nothing but your sentiment analysis. Okay, and speech recognition and all you already know, right? So we have been talking with our voice assistants from a very long time. If you are using iPhone, Siri, whatever we were having from a very long time, right? So those kind of voice assistants were also built on this deep learning. Of course it is not related to limited to that itself. We have chatbots where you are conversing every day, and Gemini live mode and all voice assistants, even Amazon Echo bots we have, right? And now the technologies have turned in such a way that even lights, turning lights off and fans are off, you need not to go and do that manually. You could simply say turn off the light and it will be doing that. Okay, so whatever we speak, so those sound waves are getting converted into some kind of text and our model is able to understand it. Okay, so that is the capability of deep learning altogether. I can simply keep that in that manner. Okay, and predictive analytics, so people, stocks and all, we have many algorithms today, right? And it is not at all limited to that. Even the temperature or weather we have, right? So based on the patterns we have in the past, we can predict the future, at least some 95%. Okay, now the deep learning neural networks are getting some accuracy around 95%. So they could, if nothing unusual happens, they could easily predict what will happen in the next day. All right, whether it is coming to weather or even your stock market or the temperature prediction or something like that. you know we have been excelling using the deep learning neural networks. And I have shown you some autonomous vehicles, right? Like a self-driving vehicles where people, they need not to drive at all. So they just sit or take a ride on that particular car, and which it drives on its own. So that particular car will be having this self-driving capabilities, right? Like it will navigate through the roads, it finds any vehicles in front of it, or it finds a lane. So all these things, if a machine is able to do, so that is all because of the deep learning. All right, so these are a limited deep learning applications I have kept. And now it is time for us to move to the uh, the topic generative AI. Okay, so generative AI, as I was telling you, generative AI is again a subfield of artificial intelligence, which mostly depend on deep learning neural networks. Okay, so as you know already, generative AI is capable of creating a new content. Okay, so whether it may be text, images, audio, video, or data, whatever it may be, generative AI is capable of doing that. Okay, so it is all about creating the new content. And if you see over here, I kept some applications of generative AI. Okay, but we know this text, image, audio, and video. If you are using chat gpt or ghibli style, or even dolly for creating the images, creating the text. And nowadays, even in youtube, we have many videos, we don't even know whether those people are real humans, or so those are all AI simulated videos, something like that. So that is the beauty of generative AI. Okay, so when we talk about generative AI, we only know this, that it can produce a content of this form: text, image, audio, or video. However, generative AI is currently penetrating into almost all of the industries we have. Okay, so almost all of the industries we have, in the sense, the drug discovery. So people are finding, so the data sequences, like mm, so what the chemical reaction we might get if we use this thing. So like that, people are using, and 3D models we have for simulations and all. Particularly the video game industry is going to boom with the generative AI, right? So you would have seen this in news. All right, so even two new movies were taken based on generative AI itself. Okay, in the last year itself, they took completely on generative AI. They did not shoot anything in real time. Okay, they completely did everything on generative AI, and I think they are going to release in the future. Okay, and so that is the importance of generative AI. And of course, we have 3D models and all, product designs and all. You might be already reading in the news every day. Okay, so when I say this, before that, we need to understand, so what is the difference between machine learning and deep learning? Did I say that? No, right? So I have just told you the applications of machine learning and deep learning, but I never said what is the difference between machine learning and deep learning. So let us see that in uh, just for 2 minutes. All right. So we have a limited amount of time, so I need to give everything in a fast manner. Okay, so data. So whenever, so if you are a data engineer, or you know a little bit about data, you already know what kind of data we have already in our real world, right? So structured data, where we have data in rows and columns, right? In tables form, in tables we have, right? So that is structured data. And semi structured data is nothing but your json or YAML files that you are having. So those are all kind of your semi structured data, so which is neither completely structured, and also nor it is uh, unstructured. Okay, so we have some type of structure form inside this json forms, just like key value pairs and all. Okay, So this is semi-structured data, and unstructured data we have a lot, right? So at least 90% of the data we have in real world now, right now, is unstructured data. For example, if you open Twitter, you can find billions of tweets over there, or social media posts where you'll find billions of photos and billions of videos and all. So those are all kind of your unstructured data itself. Okay, so that's what I wanted to say here. Now you got this unstructured data, right? Now it is time for us to see what machine learning is capable of. Okay, so machine learning especially with the structured data. Okay, so think of it a new neat rows and columns in a spreadsheet. See, structured data, if you take at least, see, some 5 to 10% of real world data is only structured data. Okay, okay, rest all, semi-structured and unstructured, only unstructured being around more than 85%. Okay, so more than 80% of your real-time data is unstructured currently. We are generating billions of messages, emails, videos and images, right? So those are all your unstructured data itself. So when coming to this machine learning, we should know what are all the drawbacks that we have for machine learning, which paved a way to invent this deep learning. Okay, so this should have some kind of drawbacks, right? So the drawbacks of machine learning being, it is fundamentally clumsy when dealing with complex and unstructured data. So whatever the data you have, something like images, right? Images you might be having. Okay, so images or text, right? So text and even the audio recordings and all, right? So those are all a kind of unstructured data that we have discussed, and machine learning algorithms can't deal with this. So if you send an image to it, of course it can't understand, it can't process it as well. Okay, so those are the drawbacks of machine learning, which made our people to invent, okay, some type of new technology, which is nothing but your deep learning. All right. So as I was telling, so deep learning is a subset of machine learning that was created specifically to overcome the limitations of its predecessor on, especially on unstructured data. Okay. So I was telling you, right, this deep learning is a backbone of uh, your generative AI. So you will find all those things now. Okay, so whatever the images we have in real time, whatever the text and LLMs we have in real time, those are all and kind of applications to your deep learning itself. Okay, even if you see over here, so picking up some tone and understanding the sentence meaning, and learns what matters in the images and all. So all these are your applications of deep learning, which machine learning algorithms failed drastically. All right, so that is the reason we have this machine learning as a new concept after all. Okay, so now you learned about generative AI. Now it is time for sorry, you learned about deep learning. Now it is time for going through this generative AI. Okay, so I was telling you from the very beginning that generative AI is built on deep learning. Okay, so whatever the artificial neural networks, right? So those are, if you, those are can also be called as deep neural networks, at least at this point of time, right? So what they do is to learn patterns and create new content. So generative AI uses the deep learning neural networks itself. So this is very simple. Okay, so if you know about heard about these transformers, okay, so they are deep learning algorithms basically to keep it precise, right? So when I say that generative AI is built upon deep learning, so it is more like a generalized way of telling it. And we have a term called as transformers. Okay, so that particular deep learning neural network is a backbone to your generative AI to keep it very precise. Of course, at this point of time you may not understand what I'm saying, but yes, so uses deep learning neural networks as its backbone, and can produce text, images, audio, code and more, whatever it may be. So hope you understood the beauty of these three technologies and how they are related, right? And so within a short time we understood the significant differences between these three, right? Yeah, so generative AI and all, of course what generative AI can do, right? So that is quite clear for you right now. now it is time for whatever generative AI is there. Mostly we are using this generative AI today for text applications, images, audio and code are there. And if I say how they are producing the text, images and audio and code, what would you say? We have some type of models which are called as your large language models. So something like a chat gpt or gemini or claude, anthropic, and so like this we have many models like which are large language models. So large language models are products of generative AI itself, that we have already known and we are seeing it right now. All right. So firstly, I would like to say what are these large language models. So if you know a little bit about it, you could tell me now. Okay. Or if not, I'll be taking up over here. Okay. So what does it mean by LLM? LLM is nothing but a large language model. Large language model. Okay. So why do we call this as large? Why do we call this as large? Why? Because this particular model whatever we are having, it is trained on huge amounts of data. Okay, huge amount of corpus, we could say corpus. So corpora, we could say millions of books, millions of websites, millions of emails, millions of social media, whatever we have right now. So these models are built upon them, I mean feeding those data. Okay. And why do we call this as a language? So why? Because this particular model is capable of handling language, and it is a in that particular language, to keep it simple for today. Okay. So it is a pro in that particular language, and it has been trained on billions of material on that particular language, and it can converse even better than us as humans. So basically we are using many applications, right, where some models are even if we speak something wrong, they are coming up and they are saying you are this is not the way of speaking in English correctly, and they are correcting us, which means they must be trained with huge amounts of data, particularly of some languages. And so hope you understood this as well. So LLMs. Okay. Now if you take any LLM and like chat gpt and all, of course they are doing wonders like anything, right? So they can answer any question related to engineering or scientific research or whatever the questions we have, they are able to answer everything, right? That is certain. And we know all about it. But even LLMs have some kind of limitations. Okay. So some kind of limitations in the sense drawbacks, you could simply call it as drawbacks. Okay. So we have some set of drawbacks to LLMs as well, that we may not know that, right? So let us look at the limitations of LLMs. So the first limitation we have is outdated information. Okay. So let's say you have this a chat GPT and you are asking it what happened today. So will it be able to answer it what happened today? So now we have an option like search in web, but if you consider this in some 6 months before, so chat gpt cannot answer any data which is very new, or the current data it cannot answer at all. So it will say that my knowledge is limited to 2024 or 2025 till January only. I can't answer from February, March, April, something like that. So which is nothing but your outdated information. Okay, so that is one thing. And if you want me to ask, if you ask me what is this second one, no access to specific or private data, let us say you are working in one company, right? So let's say you are working in some product based or MNC or whatever. So if you ask what is my company policy and what is the maternity policy I have in this particular company, can ChatGPT answer that? So that is a big doubt, right? So being a person and you are asking that application whether ChatGPT is able to answer questions related to my particular company, whatever the internal policies I have. So can ChatGPT answer that? No, not at all, because ChatGPT would have trained on billions of materials or billions of corpora. Okay, billions of text, images, websites, emails, or internet, whole internet, but it wouldn't have gone through your company specific documents, because they are they are copyrighted, right? So whatever the internal documents you are having right now, so ChatGPT will not be knowing that internal policies. So that is another limitation of these LLMs. Okay, so I just kept one example of ChatGPT. However, you can relate that to Claude or Gemini, something like that. Okay, so that is the biggest backdrop we have. And of course, limited context window is one other thing. So each of the LLM, whatever you take, it will have limited context window. So let's take this GPT models. So they will be having some 32,000 tokens. Okay, token limit, which means for now you can take the token as a word. Okay, so if you ask what is LLM is a question you are asking to a chatbot like ChatGPT. I'm sorry. So like ChatGPT, this is one token, this is other token, this is other token. Okay, and it should be producing some 4 to 5 lines of code, right? 4 to 5 sentences of information, right? 4 sentences, let's say 4 sentences, and each sentence has around, let's say, 10 words. Okay, so 4 into 10 is nothing but your 40 words. Okay, so the LLM now says that I have replied back with 40 tokens. Okay, so this is another limitation of your LLM. Okay, so what I am trying to say is that I'll show that here. Okay, so let me take out one simple example, whatever we have. So this is one text document I'm having. Okay, so this is one text document. It is kind of a textbook which has around 500 at least 500 lines of data or paragraphs we have. Okay, you're able to see my screen, right? So this is a textbook I have, and I kept my personal information somewhere inside this particular textbook. Okay, so see, so this is one thing I have kept over here. Naveen is an AI specialist, so he lives in Hyderabad, and he watched these three movies at these times, and over his career he's led deep learning projects and all. So this is some random information. Okay, and he attends AI meetups and tech events around Hyderabad and all. I kept some 10 lines of information about myself here. Okay, now what I'm going to do is that I'll open one LLM. Let me open this Gemini itself. Okay, so Gemini, and uh, one second, Gemini. Yeah, we have it here, and so I don't know why it is coming up in Telugu. I'll have to change the language. Okay, so this is the LLM. We have it. Okay, and now I'm sending this a simple text document to it, and I am asking, get me the details of Naveen, um, what movies he watched, etc. Okay, so I'm asking this particular question, and I'm sending this document to my LLM. Let's see whether it can answer or not. So these are super very advanced models, so they may answer these questions perfectly. Okay, I'm sure about it. But if you see here, I'm sorry, the file has file name is this, but contains the text of some story, but it says that it cannot find any information about the person called as Naveen. So you got this right. So this is nothing but your token limit. Okay, so whatever the information I provided in this particular text file, which is having some huge amount of data in it, so only LLM can take up to a certain limit. Okay, so it can read only till some 32,000 tokens or 32,000 words. So maybe within the first paragraphs or second paragraph itself, it will stop reading. That is its capability. Okay, so which is the biggest limitation we have today? All right. So how do we overcome this limitation? So which is important, right? How do we overcome that limitation? So that is when we got this RAG, okay, which is nothing but your retrieval augmented generation. So it is more like an additional feature to your LLM. So at least at this point of time you could remember like that. So which is your uh, additional feature that we are giving to LLM. Okay, now I have written a simple code. Okay, I have written a simple code um, with a RAG application. Okay, so let me stop this first. So what I'm doing is that I build this application with a very few lines of code. Okay. Now what I'm doing here is that I'm creating the RAG application.
Can you increase the font size, Naveen?
Sure. This is just a code. So
No, no,
you
increase the font size. We are not. I'm not able to.
this
Is
one.
it for?
So in VS Code, yeah,
Yes,
in
yes,
VS,
yes.
yeah. Can you see it?
Yeah, something
Yeah.
better.
Yeah. Hope you can see now. So others, can you see my screen now? Right? Yeah. So what I did was I just see. I'll show you once again. I'll show you once again. So I'm stopping that particular application which is created, and now let me show that once again. So it is trying to stop that application which has opened. So the application has opened, but I wasn't showing you, right. So I just closed it. So it is taking some time to refresh. So this VS Code, it is little bit slow, I guess. Okay. Okay, now again what I'm doing is that I build some application, and I am starting to run it, and you can see application is running right now with the code whatever I have written over there. Okay, so what I did in this particular code is that I have my open AI key. That is the reason I'm not showing the entire code to you, but I could show whatever the document I had, right. Very good RAG is the document. So the to Gemini I sent one text document, right, with some 500 paragraphs. So I have this document here, and I build this RAG application right now, and let us see how it will behave right now. Okay, so it has taken up that particular information entirely, and now let's see whether it is able to answer our particular question. What are the movies Naveen watched? Okay, so I'm giving this particular question to it. Let us see how it is able to answer. Let's see whether it is able to answer it or not. See, Naveen watched Kubera, Skyforce, and Patan, right? So it is able to answer the question perfectly, and you can even ask it when Naveen watched Kubera movie. So even if you ask this, let us see whether it is able to generate. See, Kubera movie Naveen watched on July 16, 2025 at 8 p.m. See how beautifully this has worked. So that is the beauty of your RAG. Okay, so that's what I wanted to say. See, whatever the information I have, what are the movies Naveen has watched, this RAG kind of application, what it will be doing is that it will fetch that particular information from the document you have, and it provides the data to LLM, whatever the LLM. And as you know, LLM is capable of answering your questions very perfectly. I mean, it knows English very well. It frames that particular answer and give to you. That is the beauty of RAG. Okay, so that's what I wanted to tell you. All right, so hope you got things very clearly, and what is the limitation of your LLM. So limited context window, even the scanning of information, it will be limited, and whatever the information it is going to provide, that will also be limited. That is the thing. over here. All right. So rag, and yeah. So it's already around 8:30, and I should be moving to these questions, right? So we should learn right. So because so this I would like to emphasize a little more, because we have we will be having millions of job openings in the coming some 3 to 4 years. All right, you would have seen how significantly or exponentially the number of jobs of generative AI has increased. And of course generative AI is penetrating to almost all of the industries we have, like drug discovery, health industries, or even IT industries for code generation or image generation, or whatever. So its capabilities are expanding like anything. And of course the number of jobs on generative AI are also increasing a lot, right? So in 2025 itself, I mean from this half year, right? So we will see a lot of job openings, right? At least from 2026 or 2025, from this November time, you will see a drastic increase of the job vacancies in generative AI. And but there is one thing, there is a huge gap in the talent and the number of vacancies that is going to create. All right, and which are all already there as well. Okay, that is the reason many of service based or product based companies, what they are starting to do is that they made generative AI trainings mandatory in your company as well. So you would have gone through generative AI trainings, right? So in your company, so those are basic trainings to have a little bit knowledge on generative AI. All right, so companies also, so they indirectly training the people to know about generative AI, right? So Accenture and some other companies, they, you already know, right? So they are spending billions of dollars on generative AI training, so $3 billion actually. Okay, and recently you would have seen Infosys also has taken up many generative AI projects and all. So you are I believe you are going through the news. So that is the demand we are going to get in the future. And this is a simple thing I would like to keep over here. This is a talent gap down the line. All right, so so that is the thing. And the generative AI job roles we have today, so directly or indirectly you have these generative AI roles. Okay, and and in the coming years, from 2025 to 27, like that, so some more generative AI jobs are going to be created, and these are the job roles basically. So these are the job roles we have, and that is a thing. All right. So and for a perfect beginning of your generative AI, how should you prepare? That is the other question we might be having, right? So for becoming a generative AI engineer, firstly, first and foremost, you'll have to start with Python, and then you should have basics of maths and statistics, right? And then you should have machine learning essentials. Okay, and then you should have your deep learning, and then you should move to NLP, which is nothing but your natural language processing. And you'll have to go through the sequence to sequence model, so where you will find this encoder decoder kind of thing, so that it will be easy for you to get information on the transformers. Okay, so transformers is also kind of encoder and decoder architecture. So only if you learn this sequence to sequence models, then you can correlate the information with this transformers. All right, so transformers, and basically you can go through this which your advanced generative AI syllabus will start from transformers itself. And then you will be looking at LLMs. And so once you are done with LLMs, you will be learning RAG. And then once you do that, you will have to go through this lang chain, right? Lang chain. So you need to build some application based on LLM you have, right? So just like the one I have done right now, which is a very simple application, right? So that I have built with RAG chain and lang chain and RAG capabilities. Okay, so that's what I have done: lang chain and llama index. Okay, and then once you are done with that, you will have to optimize whatever the applications you are doing, optimization of your LLMs, right? So where we will be talking about this RAG, whatever I have told you, fine tuning of particular LLMs, and then we will be looking at prompt engineering. So these are all nothing but your optimizations to your LLM application. Okay, so once you do that, you should know how to deploy them, right? Deployment. So how do we do that deployment? We have simple ways of deployment like Streamlit and all, Streamlit or Gradio, which are your local deployments. And if you would like to use the cloud, we will have to do the cloud deployment as well. Okay, so once you know about a little bit on cloud deployment, you should be able to deploy your code in either any of the cloud platform like AWS or Google or I mean Google Cloud Platform, which is GCP. All right, so GCP I could keep it, or Azure. So something like that, you should be able to deploy your application, right? So this is the roadmap for your generative AI application preparation. And the thing I would like to say over here is, of course, there are lots of things in between. All right, of course there are lots of things in between like embedding models and all, vector databases. So all those kind of things, optimizations and all will be coming up in between. However, I kept your preparation in a shorter level. Okay, so that's what I have kept over here. So Python, mathematics and statistics, machine learning, deep learning, natural language processing, and advanced generative AI. Okay, hope you have understood this. And so being in our institute, so what we are doing is that we are have started a program which has been running from these batches, number of batches we have taken. And this is a Gen AI job oriented program. And it will be of 3 months in-depth training. Okay, so I would like to show the brochure to you. Give me a second, please. Give me a second. So second. Yeah, I got it. So this is the thing over here. And 1 second. Yeah, this wasn't the previous batch, right? Yeah. So we have unveiled this batch where you will be going through every module I have kept over here in a very detailed manner. Okay, so it won't be a shallow kind of learning. Okay, so it will be in in-depth manner. We will be covering all these modules. Okay, so you'll be starting your preparation with or training with Python, where we'll discuss all these things, and we'll libraries, pandas, numpy and matplotlib, right? And then we'll be going through the maths and statistics, where you'll be learning this linear algebra, eigenvectors and eigenvalues, so probability and statistics and machine learning essentials. You should know, because in the recent interview calls, people are asking few things. Okay, so we would like to keep whatever the interviews they are asking 100% of the matter in our program. So that is the reason we are extending a little bit on the syllabus part. Okay, so the machine learning and deep learning, so we'll cover with the deep learning and neural networks. Okay, so now itself I would like to say we will be covering at least 20 mini projects in this program. Okay, so 20 mini projects. So I kept over here as 15 mini projects, 15 plus mini projects, but it is around 19, 20 like that. Okay, and 2 capstone projects are what we are going to cover. Okay, let me go here again, right? So deep learning. And also the thing is that you would see deep learning syllabus as a little one, but I would like to show in my previous batch how many classes we have taken for all of them. All right, so let me show that to you once. Okay, so this is the current batch or ongoing batch we have. So if you look at the Python programming and all, so these many classes we have taken for Python. And so I was telling about deep learning, right? So the deep learning, so we will have to cover so in depth on every concept, right? So though I have kept a very limited matter over here, but we will not miss out any topic related to your generative AI preparation. That is the reason we went through like this. Okay, so that is the reason, and you could do that. I mean, hope you can understand what I'm trying to say. And so once deep learning is completed, second sorry deep learning is completed, we will be going through this natural language processing, where we'll discuss on classical NLP, traditional NLP, and the modern NLP, how things are going on, and foundations of generative AI. So of course we will be starting with what is generative AI, and what are all these generative AI versus discriminative models, and what are all the models we have. And we'll see the transformers, which are the backbone for your large language models altogether, and the architecture, and we'll do the transfer learning, where we'll be doing lots of exercises or projects building on that. And LLMs, I'll be introducing you to LLMs and what are large language models, the fine tuning and all. And fine tuning, what kind of fine tuning we have. And we'll be doing a very good project on this fine tuning there as well, with some billion parameter model. And embeddings, will look at RAG, LangChain, and orchestration, Llama index, prompt engineering, and the basics of agentic AI will be covered. For some let's say uh, you will have good amount of information there as well. And capstone projects and all, we'll see to end-to-end AWS GenAI application, and the end-to-end GCP GenAI application. Okay, so this is the course curriculum I'm having. So if you have any questions, you can ask me, but I would like to say some of the features as well of this course. Okay, so the course features here being, I was telling you, right, when I say uh, we'll be covering entirely from Python, right? So it means we are not expecting any kind of prior knowledge. Okay, so whatever maybe in the domain you are working right now, maybe tester or data engineer, whoever, and you'd like to upskill or wanted to learn this generative AI, this is a kind of a thing for you to grab it. Okay, so this is one thing, we are not expecting anything, and everything will be covered in a detailed manner, even starting from Python, as you have just seen. Okay, and of course that this batch hasn't do not have some information like statistics and mathematics. We did not keep much concentration on them. We told whatever is required. Okay, and it is merged into deep learning or machine learning, but for you it will be a separate one. All right, so that is the thing I would like to say. And zero to advanced learning, so you come up with zero knowledge and you could go with 100% of generative AI knowledge. So that is the thing. And 3 months of in-depth training, I have been telling, right? So this is the thing. And so study materials, we'll provide the study materials. Let me show how this study material looks like. So this is how your study materials looks like. So entirely, so how things will go, what are all the concepts, and how the matter will be, so how the concept is related to the other one, and all you will be saying, right? So in this manner you will be going through. So that is the other thing. And of course we will be providing the interview questions to you, and assignments and exercises will be provided to you. And I would like to emphasize on few things. Okay, so which are, so whatever the presentations that we use, uh, you know so let's take this particular PPT. This is for deep learning itself. Okay, sometimes even for a very good learner, it becomes difficult to understand the concept very clearly or within a short amount of time. Okay, so that is a case for everybody. So that is the reason what I did was I have included some kind of animations like this. Okay, so which are deep into the concept what will be happening inside the model training. Okay, how things will change. So these things internally will obviously look at the code and we'll see what is happening. However, so to imagine this, you might be facing some difficulty, right? So to remove that difficulty, or to remove whatever kind of what do we say, complexity, we will have to, we have included some kind of slides like this, and even the mind maps as well, so that you can grab the concept within a short amount of time. Okay, so the mind maps like this. Okay, so these were all these will all become a part of your training. Okay, so this is only about your deep learning. Okay, so if you want me to show some other, the objective of having this is to simplify the conceptual understanding. Okay, so if I say everything as a theory kind of, so you may not understand, right? So we need to have a very good understanding what is actually happening. Okay, so that is the reason I have kept many of the animations over here to understand what is actually happening inside. Okay, so this is for your convolutional neural networks, or whatever it may be, sequence to sequence model, or even for large language models, the same thing. Okay, so there might be scenarios where you may not know, right, what is this generative LLMs and discriminative LLMs, instruction following LLMs and all. So if I keep on writing this on my board, it takes a lot of time, and I'll be taking up 1 hour of class for writing this itself, right? So that is the reason, in order to save some good amount of time for you and to make things easy where it is actually complex or complicated, so I'll be keeping animations or simulations like this. Okay, so these kind of simulations where you will get a very good understanding on how things are going on. So by looking at this, you could simply say, right, how things are going on, and that is the thing. So that is one more thing. So I would like to say this. I mean, if you have any questions, we'll discuss on that now.
Are we looking for the agents also?
AI, agentic AI, as I said, you'll be getting some good amount of knowledge, but we will not cover in detail or in thorough. So you'll have some 2.5 hours of sessions on agentic AI, but
Hmm.
the thorough and all, we will not be this. It will not be part of this program.
And the next question is, we are not covering any ML ops here, right?
MLOps is not part of it because it is again a different syllabus
Okay.
altogether. MLOps is kind of a separate domain. I mean, even learning this will be around some 40 hours or something like that. Okay, so
Yeah.
MLOps is not covered. If you
Yeah.
want to learn generative AI, MLOps is not what you want. You should have LLM ops.
Yeah.
Okay,
LLM. Sorry. Yeah.
yeah.
LLM.
So yes. So yes, that's the thing. Yes, do we have any other questions, or I see one in the chat. Uh, so what language was the code written? So it was written in Python. Okay. So the reason why we are going towards Python is that most of the frameworks you have in Python coming from the deep learning itself, deep learning, or even machine learning also. So if you are a machine learning engineer, you would be you are already using some sklearn, or these kind of libraries, right? In deep learning, we'll be using TensorFlow and Keras and PyTorch, and then we'll see NLTK in NLP, Spacey, GenSim. Okay, so all these are related to your Python itself. So most of the applications in generative AI, for now, 95%, more than 95% are based on Python itself. So that is the reason we have taken up Python, and the code I have written as well is from Python itself. So, as part of these questions, do you teach how to call GPT models? Yes, obviously, API calls and functional calls are important actually. Okay, API calls and function calling are indeed important for you, because if you are creating applications, being a generative engineer, so you are supposed to keep API calls. We will have to use OpenAI GPT models, OpenAI DeepSeek, or Gemini. So all these are part of your program itself. So we'll be doing OpenAI calls, AP, OpenAI GPT calls, and Llama, open source LLM, right? So Llama and Gemini. So we will be doing this all API calls. Not only API calls, we will be doing functional calling as well. Okay, so that is other thing I would like to add, because these are all important. So if you want to build up a model, just like chat gpt, it will take months of time with the billions of dollars to be spent. So that is the reason we simply use whatever whatever API we have it. Okay, so that is the thing. And we have one more question: what is functional calling? See, for example, let's say you take chat gpt. Okay, so you take chat gpt, and chat gpt, does it know what how is the weather outside in Hyderabad today or in Bombay today? It doesn't know that information, right? So it has to get that information from a real time weather application or weather API. So weather sending companies will be there, right? So from here it has to grab that information, and it has to provide to user. Okay, so this is one such example of a function calling. Okay, so ChatGPT may not be knowing everything, right? So it has to get information from others as well. So that is it. Yeah, yeah, hope you got it. Yeah, thank you. And do we have any other questions? So if you would like to know more about the program I was telling you, right? So uh, any kind of prior knowledge is not at all required, because we are going to cover from zero level. All right, and it will be for 3 months in-depth training. And I would like to keep this as well. So the batch timing will be from 7:30 a.m. to 8:30 a.m. IST. Okay, so that is the thing. And do you have any further questions? So I'll be happy to help and I would like to show
Yes.
few more things as well. Yeah, please. Yeah, please carry on.
Yes. Can you show us the capstone project that you have, the two capstone project?
Yeah, that I'll be showing in the tomorrow's demo. So the structure and all
Uh,
I'll be showing in the tomorrow's demo. Yes. So do we have any further questions? So that is the thing. And if you have any kind of questions, you can ask me, or we will wind up the session. So whatever the uh, things I have told you till now, right? So these are all will be covered, right? So this is very important question that one of our audience has asked: what is this functional calling? Yes, we have a class tomorrow, which is again a free demo. So you can also attend at the same time. Okay, which where I'll be explaining you deep learning. So tomorrow's session will also be interesting, where I'll be taking you through the domain of deep learning. So I have given enough hype on deep learning, right? But you should understand what is this deep learning, and how the model training will takes place, right? So those things we'll cover up in tomorrow's session. Okay, so that is the thing. And if you would like to enroll to our program, you could simply follow the messages that our management is putting over here. So you just take help from them how to enroll to this program and all. They should be able to tell you the fees of this program, or what is the process to make a payment and all, how to enroll to this batch to keep it in short. All right, that is the thing. Okay, so hope you got what I'm trying to say. And So this is gist of it. I kept only few points over here, but I can't write everything down, right? So I did not keep. But what I believe is that, so let's say it is, the program is for around 3 months. Let's say 3 months, 3 months Monday to Friday. I believe that on the let's say some 90 hours. So on the 91st day, you could go for the interview. Okay, so that's a kind of assurance or kind of thing I'll be giving to you. Okay, so that is the thing. So basically, whatever may be the technology, so kind of generative AI, so I'll keep my, as a trainer, I'll have to keep some good amount of effort to make things easy for you, and to make in a in-depth manner. Okay, that is important. In-depth manner is something important. Okay, so to do that, even you will have to work from your end as well. Okay, so that is the only thing I expect. So do we have any other questions? So if not, we can wind up the session because it is already 8:52. So I'm getting messages from one of the few of the people, right? It is extending kind of.
Naveen, do this program into the graph rack.
Graph rag.
Yeah. So
Oh
do
yeah. I see that question. Yes. So this rag graph, so it is not usually the graph rag. So it means a graph based structure, like in technical or in code context, right? But rag itself is not a graph model actually. Okay, so I personally do not know what this graph rag is all about, but rag and all we'll be covering in detail. Okay, so this is this a type of rag I'm asking?
yes.
Yeah, so maybe I'm using a different terminology over here. So if you take up some of the examples, right, in the rag itself, so people will be calling different things. Okay, so a few people will call it as a graph rag, and few people will call it as a different thing. So graph based architecture will also look like, so whatever I have in mind, so graph based architecture will also look something like your agentic AI workflows. Okay, so it is related to that. Okay, so when basically during RAG, I won't be covering more on this graph RAG, but in agentic AI, I'll have to differentiate between things. So I'll be explaining there over there. Yes, thank you. So do we have any further questions? So we can take up all the questions. Or so will this generative AI help with prediction? What kind of prediction I mean? Um, so prediction in the sense, right? What I'm getting in my mind is that the regression kind of, or see whatever the LLM. So LLM, if you ask me about prediction, what LLM will be doing is that it will be predicting what is the next token. Okay, so predicting the next token is nothing but what the functionality of LLM is all about. Okay, that we'll see in the regular classes, but the thing which is coming into my mind is this thing. Okay, and even regression kind of methods is also type of prediction. So I would take that in that manner. If you have a specific question, you can ask me, and I'll be able to answer that. Okay, so if you do not have any further questions, probably we can wind up the session. And if you have any doubts and all, you can check with our management, and they'll be able to answer all your doubts. Okay, so like this, I keep things as simple as possible. So these kind of diagrams and all, you may not find in the internet, right? So you may not find them obviously in the internet, because I have simplified most of the concepts over here, so like this and all, right? So that's the thing I would like to say. and you can check with your with our management, and you can come up with any kind of questions you have. Okay, yeah, thank you so much. So if you do not have any questions, we can wind up the session, right? Yeah, thank you
Naveen,
for.
just one more thing. So, do we get a recorded session as well, right? The links?
Yes, you will be getting the recorded session every day.
Okay.
Yes. So basically, we'll create a Telegram group for you as well. So there we'll be sending any kind of information and all, and the recorded sessions they'll be loaded to your Google Drive each and every day once we once the class gets over.
Got it. Thanks.
Yeah, yeah. So yeah, that's it from my side. And I have already shown you this, right? So the classes will be from 7:30 a.m. to 8:30 a.m. All right. So the course feature and all, whatever we discussed, right? Machine learning, deep learning and all, we'll discuss them in a thorough manner in our regular classes, as I have a time constraint of 1 hour to keep things as fast as possible. I would have rushed at a few points somewhere around here or over here as well, right? So please don't mind on that. Because of this time constraint, I would have explained these things in a far better manner, right? Yeah, so that's it from my side, and if you have any questions, you can check with the management, and they'll be probably able to answer all your questions there. All right, so the classes will be starting from Monday onwards. So please get that in confirmation, right? So I mean the enrolling and all you take from the management itself, and they'll be able to deliver that. All right. So yeah, thank you so much, and have a great day.
Thanks, Naveen. Have a good day.
Thanks, Naveen.
Thank you. Yes, please tell me. This is the demo. This is a free demo. Yes, this is not a regular class thing. So this is a free demo, just a free demo. Till tomorrow only. So tomorrow will be the last demo. Yes. Yeah. Oh, okay. Thank you so much for the compliment. I mean, I take it as a compliment actually. Yeah. Thank you. Thank you for the compliment. Yeah. Thank you.